This is part 2 of our notes for analyzing categorical data. This is a two-way table. A two-way table describes two categorical variables. That's what a two-way table does. It's going to describe two categorical tables. And so this one here, it says the Pew Research Center asked a random sample of 2024 adult cell phone owners from the U.S. which type of cell phone they own. Here are the results broken down by age category. So we have iPhone and Android, and then we have other. And you can see that they broke it down into age groups, 18 to 34, 35 to 54, 55 plus. And then they have totals for each. They have the total number of iPhone, the total number of Android, and then the total number of other. And then they have a total for everything. So the marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all the individuals. So the marginal distribution is about talking about each separate thing. So the first one might be the marginal distribution of each type of cell phone. Might say, so for iPhone, there are 467 out of 2024 total. And so if we divide that out, we're going to get 0.231. And I did the math earlier, so I don't have to have my calculator out. So it's 23.1%. Probably get it out just to make sure I have it right, but I'm pretty sure I do. 24, let's check it. Yeah, 23.1% if we round up. And so the Android is going to be here, which is 503 over 2024, which is 24.9%. And then our other and I don't know what the other would be. I guess flip phone, or I'm not really sure. And you could see 55 plus, so maybe that's what it is. 1,054 over 2024, and that gives us 52.1%. And they should add up to 100%. There is a rounding error because when we round, you get a little bit. When you round up, we rounded up for this, rounded up for that. So it ends up being like 100.1%. So that means there's a little bit of a rounding error, but that's okay at this point. So then they ask for a bar graph. When you make your bar graph, you want to make sure that your bars are the same width, and you want to make sure that your information here. So I'm going to start at 20%. So I'm going to kind of make a little squiggle mark, and I'm going to start at 10%. So 10, 20, 30, 40, 50, 60. And if I actually do the counts, which are up here, instead of my percentages, I know that iPhone is at, or I'm sorry, if I did the percentages, I just said that. So 10, 20, 30, 40, 50, 60. So the iPhone is at 23.1, so we're about right here. And I just want to try to make sure that everything is about the same width. My Android is about the same, but not much bigger, so I want to be careful. And then my other one is at 52, so I want to go about right here. And again, I want to make sure that when I do this, I want to use graph paper or use a ruler to make sure everything is about the same. Okay? And next is what kind of distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. That's called conditional. And it depends on each value of the other variable. There is a separate conditional distribution for each value of a variable. And how do we know which variable to condition on? So how do we know what we're talking about? Well, usually we're going to be told So usually we're going to be told, but we want to think about independent versus our dependent variables. And what are we looking at? We want to think about explaining or explanation versus response. We want to think about what is manipulated versus measured and all of that. So when we look at the data that we had earlier and it says we want to make a segmented bar graph, well, our segmented bar graph is we're making the bar graph of information, but we're putting all the different parts in. So for example, I'm not going to do the whole thing because I don't think we really need to. The iPhone said from 18 to 34, there are 169 people. From 35 to 54, there are 171. And 55 plus, there are 127. So what you want to do to make that segmented bar graph is you're going to have your bar graph with your total, that this would be at, 467 would be my total on my y-axis. I made a really long line there, but I didn't really need to, but that's okay. And so my segments are going to be kind of broken down, and you can see this might be my 169. This, just to mark it, would be my 171, and then this might be my 127, but the whole thing is going to be all of the data. So the whole thing is all of the amount that we've actually figured out for our data, like how much there are total in our thing. But if we have relative frequency, we're going to do our percentages. We're going to figure out what our percentages are going to be. So we're going to take 169 out of 467. And that's going to give me my percentages for each little segmented bar graph. And that's going to tell me how to do that. Okay, that's what a segment. When two variables, if we know the value of one variable and it helps predict the value of the other, that's called an association. That means there's an association between the variables. If there is no association, that means it's independent. Means they don't, affect one another. And so how do we tell? If we look at a graph, how can we tell? We can tell that they're going to have the same bars, they're independent, no association, versus association, different bars, and dependent. So association means dependent on one another, where if there's no association, they're independent. So the cell phones example says explain what it would mean if there was no association between age and cell phone type. Well, it really doesn't help inform what type of phone they have. So it would be knowing the age of a person does not help inform what type of phone that they have. Based on this data, is there an association? Well, there is. Looking at the other graph, there was an association. You could see that if we go back to the data right here, you can see that there were more people at different age groups with certain types of phones. You can see this age group here, right here, 55 plus, had another type of phone. There's a huge number there. And so you can see that there is an association between the phones and the ages. It says to the right is a graph showing the relationship. Oops, I went too far. The number of floors for the 4 of the world's tallest buildings. What is wrong with the way the information is presented in this graph. So we've got the number of floors. We go 80, 100, 120, 140, 160. And then we've got this. So the graph itself is talks about the number of floors for 4 of the world's tallest buildings. It looks like it starts at 80. So it looks like this is a really small building, but it's really not. It's got 80 floors. So that's what's wrong with this. Really, they need to have a little squiggle here or start at a lower number, because otherwise it looks really bad. Okay, and so that's just looking at some graphs, and we're going to look at some other stuff in a little bit, but that's graphs for now.